What's up, everyone? I'm here to record possibly the last video, at least from the ones I planned, about the advanced techniques of TypeScript. The idea here is right now to focus entirely on generics. Generics are the best tool we have to avoid the anytype, which we discussed in the first video that we should never use. Let me change my mind. And generics are, as the name suggests, a generic way of typing a variable in TypeScript. So even though it has a type, you can use different types for this type and it will still work. It might sound a little abstract right now, but we'll get into the code and hopefully it'll be simpler. All right, before we get into it, please like the video, subscribe to the channel, you know what to do. All right, let me change the scene here. First, we have a function called sort, and this function sorts. It just calls the method sort from the array. But I don't know what kind of array right now. Is it an array of number, of strings? How do I type it? A dumb way of typing it would be an array of any. So we could pass any value, and this function would return any value also. But we don't want that because that disables TypeScript. Here's where generics kick in, because we can pass an expression here, anything at all. You'll see in many places people just call it T, U, V. That's normal, but I think it's debatable whether it's the best way to write code. Is it readable? Anyway, I might use a lot of T's here just because I'm not that creative with names and it's just a video. I'm not trying to put that much meaning into anything. But anyways, all right, I'm creating this type here and I'm passing here to say that this is a list of T. How does it work in the end? There are two ways of working with generics. The first one, I explicitly pass this type. For example, right here, I can say that it's a number since I want to match it here as an array of numbers. Make sense? But another way is to let TypeScript automatically infer. It's also valid to do it like that. It depends on what you're building. So you can see that right here, it already understands what's happening, that this is an array of number. But how the hell does it know just by what I passed here? Because it tries to match the value here. For example, if I just put the T here, all right, this is T, it will, let me show you, it still work. It also think that list is an array of numbers because it's getting the value that I passed here. But right here, how does it know that list has the method sort? It doesn't. So that's why I'm typing as an array of T, because I am saying, hey, this is most definitely an array. And when we pass that code here, right now, TypeScript is not assigning an array to the T. It's trying to match this shape. So it matches by getting the type of the elements of the array and say, hey, that T is number. You get it? So this is just TypeScript trying to fit whatever I'm passing here into that. That's how you should think. It's simpler than it seems. So yeah, it's fixed. So even if I pass an array of strings, you can see that it knows that it's a string and returns an array of strings. What if I pass a number here and a boolean? Then it expects, it says that T, now it infers as string or number or boolean. Here it is, it receives list, which is a list of boolean or number or string, and returns an array of boolean or number string. Simple as that. That's the basic of generics. That's how it works. We could pass other variables here and assign to other stuff, but I'm not going to do that right now because first, let's dive into a slightly different topic because right now we are inside functions. But how does it work with interfaces? So here I have an interface. You see an any here. So here I have an interface and it is a response. And the response can either be an object with data with something that I don't know, with status success, or it can be just an object with status error. without the data. All right. But let's agree that sucks because I don't know what the hell is data. Is there a better way to do it? Yes. So I can, for example, sorry, not here. I can pass our t here, which could be something. I'm gonna call it something else, just so you know, can be called something else. Data type. I'll just call it data, and I'll say data is here. So, for example, if I want to do a request for users, I can create a user response saying that it's a response. I'll create a user here, like interface user, name string, what else? Come on, Copilot, age, number, anything else? That's it. That's our user. So I'll just pass the type here. We can do it in line, like here. I could add the age number, but just to make it more beautiful. So user response, it's a response user. If we check its type here, it's either an object with status error or data user status success. Ain't that cool? Come on. That's very useful when we are working with requests, because if we add any here, we just disable TypeScript. If we add unknown, we don't know what type of data, what's the type of data, and we can't access the properties of it. But that means we know because we passed something. All right. So I hope it's clear how it works in both functions and interface and in here types. It could also work here in interface, but let's continue. Restricting values params. So once again, let's have a function, and this function receives a value here, and I want this value to call the toString, return the, not the toString actually, to lowercase. Yeah, a method that only exists inside strings. But I don't know the type of t, but I want it to be restricted to a string. But Kevin, isn't string a type? Yeah, but let me explain a little better. Let's say I have a t here and the value t here. And here I'm saying that t extends string. And I know that lowercase string is also from type t, for example. Why is it complaining? String is not assigned to type t. Let's see. Oh yeah, because I can just assume that, I can't just assume that the lowercase one would be of the same type. So in this example, it would be useless. But check what I'm doing here anyways. I'm restricting to a type string because I could call it, let me just remove for a second. I could call it, let's say func. Let's say I have a type response that is either success or error. I could still call func to do something with success, and success is of type response still. But I want to do something. I'll just return the on value. I know I will return something that is still of the type response in this case. So if I have a const a here, it is not simply a string. It is a response. And a response, success or error. But yeah, this example isn't good just because I'm doing nothing with the string. But I'll give you right now an example that it would make sense for us to restrict the value on the next topic here, which is object params. It's still restricting values. What if I had a function called, doesn't matter, once again, the function, I'll write it. All right, that's just a good example. I am saying whatever, return, whatever. I am saying that this function expects an object with name strings. But not only that, it is restricted to that value. It means that, for example, if I call func with an empty object, won't work. With age 12, won't work. But if I pass in name John, it will work. All I'm doing here is restricting the object to contain that name. Could be something else, such as length, number. So this function right now will be get length. And I know the objects have length, so it will just return the value length. And right now it's not a thing anymore, but if I put the length here, yeah, it works. Let me just check it. Cannot find name func. Oh, now it's get length. So I hope it's clear how restricting values using another type to restrict makes sense better than the last one. So yeah, that's the very basics about generics. Right now, I'm gonna do an exercise which will be a strongly typed reduce function. I hope you know what a reduce function is. It's one of the array methods we have, reduce. I'm gonna create a reduce here, and maybe I should disable Copilot because it's suggesting a lot of stuff. It might be annoying. But what it will do, it will receive a list. It's suggesting everything already. The reducer, which is the function that is called every time, initial value, of course. And that's it. Right here, we will have the current value will be initially the initial value. But for, is this correct? That's correct. For each element on the list, I'm gonna call the reducer, passing the current value and passing the current element on the list. And also the reducer receives the index, so I, and it receives the whole list. That's how it works. And in the end, it returns the current value. That's the reduce function. If I have to type it, we'll start by creating a generic T for the list because it's a list of T. Also, the initial value and the return value must be of the same type because, for example, if it's reducer that goes through an array of numbers and returns the string with all the numbers, then the initial value, I'll create another generic here, U. We'll have to match that. We'll have to match the return of the function and also the return of the reducer function. So if I do that, it returns U, but the reducer also receives the current value, which should be also the same type of the initial value, which is U. Initial value U will receive the list element, the current element. Let me put it like that. Current element, which is of the type T, since the list is an array of T. It will receive the index, which is a number, and the whole list, which is an array of T. And that should be right. Let's see what's wrong right now. The reducer expected 5 arguments. 5 arguments. Initial value. Oh, not the initial value. It's the current value, but that's not what's wrong. Current element, which is of the type T. The index number, and the list. What the hell? Oh, I didn't declare the variable name here. I'll just call it list. So now it should be correct. Yes, that's a reduce function. So let's suppose I'm gonna use it to sum something. Let's say I have an array of 1, 2, and I want the sum of them to be reduced, passing the array a function. Let me declare this function down here. This function will receive, let me see the order, the current value and current element. That's what matters to me. And I'll return the sum of them. And the initial value of the reduce will be 0. So the sum here, the reduce here, as we can see, receives a number and returns a number. That's what matters to us. Let me do another one. Instead of return the number, I'll always return a string. So the initial value will be empty string. And right here you can see TypeScript working because, hey, the current value that I'm accumulating is not matching the initial value type, which doesn't make sense. So right now, what I'm gonna do is I'm gonna always add the current value, this dash, and the current element. Yeah, you should add 1, dash 2, 3, and 4. And the types are correct, I assume. T is a number, S is a string. So we pass a number and receive a string back. That's awesome. All right, I hope this example was clear. I know it's not very trivial, but I hope it was clear. Feel free to leave comments asking questions. From now on, I'll try to be a little faster because I have a lot of examples here just to show some cool tricks you can do with generics. But right here, I'm creating a type called element type. My goal here is if I have an array, a type of array, let's say an array of number, I want to be able to pass and get just the number. But if I just pass number, I'll get number. It's a type of the element that I'm passing. Element type receiving something, which we don't know what it is yet. I'm saying that T, I'm not saying actually. Those are conditional types. Extends, infer U array. Here, this is a keyword to make TypeScript try to infer a type of something to match the whole thing. So right here, T needs to match. Try to infer a value for U so it's an array. So for example, if it is an array of numbers, then it will try to match and U will be a number. Then this expression is true because it could infer the value. We got a match. Then what was a match? Number. That's what we get as response. If let me call it const A, and I'll do a type something, whatever, is element type of A. Then something is a number. But what if, let me even type explicitly here, now it's a number. Now, like A is a number and not an array of number. Then it will try to infer a value so it matches an array, and it won't be able to because that's not an array. So it will be the equivalent of a false expression, and it will return the last value of the ternary. That's how ternaries work, which is the own value T that I passed, number. I know it might be confused, but please watch it again if you didn't understand. If it can match, true, returns U, whatever we inferred here, or TypeScript did. If it doesn't match, false, then we just return the value that we got as input, which is number. All right, deal? Something's number again. I hope that's clear. Let's go to the next one. Doesn't get better than that. Just kidding. I want to show you some tricks with template literals because we can use them with TypeScript to create some cool types. For example, I have a type HTTP method, which can be either the string get or post or put or delete. Then I have an endpoint that receives a generic value method that I restrict its value with extends to HTTP method. So method can only be one of those. I cannot have endpoint passing something else. And then this type is method, one of those, slash a string. What it means is basically, for example, get something, it's of the type get endpoint get, and any variable that I create after get something needs to be get space slash, because it's declared here, whatever. If I type anything here, it works, but if I remove the restricted part, it breaks, not assignable. Another example with template literals. So let's see this one. I have that response status is success or error. Type response body. This one is cool. I know it's a little confusing, but it's cool. We can use in to restrict values, just like extends, inside of keys of objects. Response body is an object that the keys are, I'm going to read this one from right to left, this interpolation. Key message, but notice who is key? Key in response status. So it can be either success message or error message, the key with the value of a string. For example, I have here response with, which is the type of response body, is of the type response body. So the keys here are success message and error message. If I try to create anything else, it won't work. Yeah, and I just wrote anything as a string later because we just have a string generically. There's a cool one because right now I'm gonna use recursion to create the type. Let me even decrease a little bit the size so we can read the whole thing. In this example here, this one doesn't have TypeScript, but it's just to explain the next example. I want to create a type that knows that the text will be of type A or B or C. Get it? Because I'm splitting it by the vertical bar. The type split receives S that extends strings and delimiter that extends string too. It receives the following type: S extends. So notice that this whole thing is a template literal. Infer start, it will try to infer the start, delimiter, and then the rest. If it can infer that, in this example here, for example, it would get the A, delimiter, and then the rest. Then it will return, because it's true, the start, A, and the rest of the split rest delimiter, which is the same function, so the same type. I'm doing a recursion. What is the rest right now? B, vertical bar, C. So it will try to put here start, B, delimiter, vertical bar, and rest, true. Then right now, if we spread the value, we'll have A, B, and now, once again, we call the split with the C and the vertical bar. When we call with the C, we won't be able to match this because C won't find the delimiter, so it will be false, and we'll return just the array of C and spread it, so A, B, C. I know that one was hard, but let's see it in action. Type something. It's split A, B, C, passing this delimiter. So right now we have an array of A, B, and C. Cool. I hope it wasn't that complicated. Rewatch this part if it is. Right here I have another example using it, which is simply the split of this URL passing the slash. I would get the example.com, delimiter home, delimiter about. Those would be the path parts that I need to declare. Say that's not cool. If I open the string here, it already suggests me the example.com. For this next one, the same, home. And for this next one, same, about. So the text editor is pretty cool. And all right, the next part, I just want to show about how you can create some types, and I won't dedicate that much time to it. This first one is a little useless, it seems, but the concept is cool because mapped type. Let's say I have a type, mapped type, whatever, will be of name, string, and a number. Same example once again. Mapped type receiving P, which is this type of object. P in the key of T, key of T. So P is limited to key of T, which makes us know that it can be either name or age. And the value of it would be the T, the object, receiving its key. All right. So basically, I'm rewriting that type. It's the same thing. Name, string, age, number. I just iterated, and we still have name, string, age, number. Why did I show you that if it's useless here? Because we can do some cool tricks with it. Because here, I recreated the utility type partial that I showed on the first video by doing that and just adding a question mark here. I'm basically saying it's the same one, but the properties are optional. For this other one, nullable, which is another utility type. I'm doing the same thing as here, but instead of simply having that, I'm saying, hey, it can be the value or null. The values are nullable right now. That's why it's called nullable. And this other one, read only. Same thing as this one, but with the keyword read only. So you can't modify the properties. And that's it. That's what I prepared for you. I really hope you enjoyed, that you learned something out of it. I'll try to make that available. So check the description for it. I appreciate you watched this video until now. So please leave a like at the video and subscribe to the channel. Leave comments, and that's it. Thank you all.